Hello, everyone. Today, let's talk about the future of our sun. The colossal star that lights up our days and provides us with warmth. Will it really die one day? Imagine if the sun stopped producing energy and plunged the Earth into darkness. Is this scenario only found in science fiction movies, or could it actually happen someday? Just like everything in the universe, the sun has a life cycle. Currently, it shines brightly, illuminating our world. But billions of years from now, it will start to die out. What triggers this process? Why does the sun eventually die, and what does this mean for Earth and the Milky Way? In today's video, we'll explore the life cycle of the sun, the process of its demise, and the potential impacts of this catastrophe on us and our galaxy. If you're ready, let's embark on a journey into the depths of space and find out what happens when the sun takes its final breath. The sun is our colossal energy source, lighting and warming our planet every day. But have you ever wondered how the sun produces this energy? Let's dive into the heart of the sun and see what's happening inside this enormous star. The energy of the sun comes from nuclear fusion reactions occurring in its core. In this process, hydrogen atoms combine to form helium atoms, releasing an immense amount of energy. This energy travels outward to the sun's surface and then radiates into space, reaching Earth and other planets. The internal structure of the sun is also quite fascinating. The core is where energy production happens, surrounded by the radiative zone and then the convective zone. In the radiative zone, energy is transferred outward by radiation, while in the convective zone, hot gases rise and cool gases sink, similar to the motion in a lava lamp. The surface of the sun, called the photosphere, is where the sunlight we see is emitted. However, the sun's atmosphere, known as the corona, is even hotter and more mysterious. The corona can be observed during solar eclipses and remains an area of active research for scientists who are trying to understand why it is so much hotter than the photosphere. Currently, the sun is about 4.6 billion years old and is in its main sequence phase. During this phase, it continues to convert hydrogen into helium in its core, a process that will last for several billion more years. But eventually, the sun will exhaust its fuel and begin to die. So what exactly happens during this dying process, and what does it mean for Earth and the Milky Way? In the next part, we'll explore the stages of the sun's life cycle and how this transformation unfolds. Get ready, because this journey is both dramatic and awe-inspiring. Now that we understand the sun's current state, let's delve into its life cycle. What does this process entail, and what transformations occur along the way? Let's take a closer look at the journey of our massive star. The sun began its life about 4.6 billion years ago from a massive cloud of gas and dust that collapsed under its own gravity. This collapse generated intense heat and pressure, igniting nuclear fusion reactions in the core, and thus, the sun was born. During this process, the sun started converting hydrogen into helium, producing immense energy. This initial and longest phase of the sun's life is called the main sequence phase. The sun is currently in the middle of this phase, steadily converting hydrogen into helium. However, this fuel will eventually run out, leading to a dramatic transformation. When the main sequence phase ends, the sun will enter the red giant phase. During this phase, the sun's core will contract while its outer layers expand, engulfing the inner planets including Mercury and Venus, and potentially reaching Earth. Life on Earth will become impossible due to the intense heat and expansion of the sun. In the red giant phase, helium atoms in the core will start to fuse into carbon and oxygen. This process will continue for a while, but eventually, the sun will run out of fuel completely. At this point, the sun will eject its outer layers into space, leaving behind a dense core known as a white dwarf. The white dwarf phase is the final stage of the sun's life. In this stage, the sun will no longer produce energy and will slowly cool down over billions of years. Eventually, it will become a cold, dark object known as a black dwarf. However, the universe is not old enough for any white dwarfs to have cooled into black dwarfs yet, so this stage remains theoretical. The dramatic evolution of the Sun will not only impact life on Earth, but will also have significant effects on the Milky Way galaxy. So, what exactly happens when the Sun dies? And what are the implications for our galaxy? In the next section, we'll explore this catastrophic scenario and uncover what lies ahead. Let's continue. Now that we've learned about the Sun's life cycle, what happens when it finally dies? The answer to this question is dramatic and potentially frightening, both for Earth and the Milky Way galaxy. Let's take a closer look at this catastrophic scenario. When the Sun begins to die, the first significant changes will occur on Earth. As the Sun's energy production ceases, temperatures on Earth will plummet. The warmth we currently receive from the Sun allows life to thrive. But without this energy, our planet will quickly freeze. Average temperatures will drop to sub-zero levels, and the oceans will freeze over. This would spell disaster for all life forms on Earth. The Earth's atmosphere will also be heavily affected. Without the Sun's energy, atmospheric circulation will halt, leading to the collapse of our climate system. Without sunlight for photosynthesis, plants will die, causing a collapse in the food chain. Animals and humans, being part of this chain, will face enormous survival challenges. The death of the Sun will not only impact Earth, but also the other planets in the solar system. Mercury and Venus, being the closest planets to the Sun, will be the first to experience significant changes. These planets will rapidly cool, and their surfaces will undergo substantial transformations. Outer planets like Mars, Jupiter, Saturn, Uranus, and Neptune will also be affected, experiencing major changes in their atmospheres and surfaces. In the broader context of the Milky Way, the death of the Sun will be a notable event. The Sun serves as a reference point for many other stars and systems in our galaxy. Its absence will disrupt the gravitational balance within the solar system, potentially causing planets to shift in their orbits. This event could also have a ripple effect on the dynamics of the Milky Way. The Sun plays a role in the gravitational interactions within our galaxy, and its absence could lead to shifts in the orbits of nearby stars and systems. Over long periods, this could alter the structure and stability of the Milky Way. While this scenario might seem distant and unlikely to affect us soon, it's a significant consideration for scientists who study the future of our galaxy. Now, let's explore how scientists are preparing for such a possibility, and what measures are being taken to mitigate the impacts of this potential catastrophe. The death of the Sun will not only be a local catastrophe for the solar system, but will also have far-reaching effects on the Milky Way galaxy. What could these effects be? Let's delve into how this major galactic disaster might unfold. The Sun is one of the billions of stars in the Milky Way, but for us, it holds immense importance. The disappearance of the Sun would lead to significant changes in the galactic dynamics. The loss of the Sun's gravitational pull would cause disruptions in the orbits of the planets and other celestial bodies in the solar system, potentially leading to chaotic movements. The absence of the Sun would also impact the gravitational interactions within the Milky Way. The Sun acts as a gravitational anchor for many objects, including asteroids and comets. Without its gravitational force, these objects might drift into new orbits, potentially leading to collisions or other dynamic changes. On a larger scale, the death of the Sun could alter the star formation processes within the Milky Way. The Sun's gravitational influence helps to collect gas and dust clouds, which are essential for the formation of new stars. The loss of this influence could lead to a decrease in star formation rates in certain regions of the galaxy. Furthermore, the disappearance of the Sun could have indirect effects on other stars and planetary systems. Nearby stars might experience changes in their orbits due to the shift in the gravitational balance. This could lead to disruptions in existing planetary systems and potentially trigger new phases of star formation or even stellar collisions. Although this catastrophic scenario is billions of years away, understanding its potential impacts is crucial for our long-term understanding of the galaxy. Scientists are continually studying the life cycles of stars and the dynamic interactions within galaxies to better predict and prepare for such events. Now let's explore how scientists are preparing for the potential demise of the sun, and what measures are being taken to ensure the survival of humanity and our planet in the face of such a distant but inevitable disaster. We've learned about the potential impacts of the sun's death on the Milky Way and the solar system. But how are scientists preparing for this eventual catastrophe? Let's dive into the strategies and measures being developed to mitigate the effects of such a scenario. Scientists are aware that the sun's death is billions of years away, but the advancements in technology and science over this time can significantly enhance our preparedness. One of the primary focuses is on space exploration and the development of alternative energy sources. Space exploration is a crucial aspect of preparation for such catastrophic scenarios. Scientists are working on. We've learned about the potential impacts of the sun's death on the Milky Way and the solar system. But how are scientists preparing for this eventual catastrophe? Let's dive into the strategies and measures being developed to mitigate the effects of such a scenario. Scientists are aware that the sun's death is billions of years away, but the advancements in technology and science over this time can significantly enhance our preparedness. One of the primary focuses is on space exploration and the development of alternative energy sources. Space exploration is a crucial aspect of preparation for such catastrophic scenarios. Scientists are working on discovering new habitable planets and moons within our solar system and beyond. Mars, for instance, is seen as a potential candidate for future human colonization. NASA and other space agencies are actively working on missions to send humans to Mars and establish permanent colonies there. These projects could ensure humanity's survival even if Earth becomes uninhabitable. In addition to space exploration, there is a strong emphasis on developing alternative energy sources. If the sun were to die, Earth would rapidly lose its primary energy source. Therefore, scientists are investing in renewable energy sources and advanced technologies like nuclear fusion. Renewable energy sources such as solar, wind, and hydroelectric power are being developed to reduce our reliance on the sun. Nuclear fusion, which mimics the energy production process of the sun, holds promise as a nearly limitless and clean energy source. Another critical area of preparation is advancing space technology. Space telescopes, probes, and other advanced instruments allow us to study distant celestial bodies and predict potential cosmic threats. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope help us understand the universe's dynamics and identify solutions for potential cosmic disasters. While concepts like reigniting the sun or creating a new star might currently seem like science fiction, they could become feasible with future technological advancements. Scientists are exploring these radical solutions theoretically, aiming to develop practical applications that could one day save humanity from cosmic threats. International collaboration is also vital in preparing for such events. Scientists and governments worldwide are working together to develop contingency plans and strategies to address global catastrophes. This cooperative effort ensures that we are better prepared to face and mitigate the impacts of potential cosmic disasters. While the sun's demise might seem like a distant concern, understanding and preparing for such a scenario is essential for the long-term survival of humanity. With continued technological and scientific advancements, we can be better equipped to face these cosmic challenges and continue exploring the universe's mysteries. Today, we've embarked on a deep and thought-provoking journey into the future of our sun and its potential impacts on the Milky Way. The sun, our colossal energy source, will one day die, leading to significant changes for both Earth and our galaxy. We learned about the sun's current state and how it generates energy through nuclear fusion. The sun is currently in the main sequence phase, but it will eventually evolve into a red giant and then a white dwarf, leaving behind dramatic changes in its wake. When the sun dies, Earth and the solar system will undergo drastic transformations. Rapidly dropping temperatures, freezing oceans, and collapsing climate systems will make life on Earth impossible. The broader dynamics of the Milky Way will also be affected, leading to changes in the gravitational balance and potentially altering the galaxy's structure. Scientists are actively preparing for such scenarios by investing in space exploration, developing alternative energy sources, and advancing space technology. Projects aimed at colonizing Mars and harnessing renewable energy are crucial steps toward ensuring humanity's survival. While the sun's death is a distant event, understanding and preparing for it is vital for our long-term survival. Continued advancements in technology and science will help us face these cosmic challenges and explore the universe's depths. If you enjoyed this video, please subscribe to our channel, like this video, and turn on notifications to stay updated with our latest content. Share your thoughts and questions in the comments below. Let's continue exploring these fascinating galactic stories together.